Hello, good afternoon. I am Kenny Gryp from the Belgian Waffle Productions, and I'm going to talk about MySQL Group Replication and or MySQL InnoDB cluster. And I spent some time just evaluating both Group Replication and InnoDB cluster, and I'll present a little bit what Group Replication is and also what my findings are with this. Actually, back in beginning of 2016, Group Replication was GA, and I did my first initial review. And a lot of issues were fixed by Oracle at that time. And yeah, this is my second iterations of suggestions that I have or best practices on how to use Group Replication. But let's take a step back and start with the beginning of what Group Replication is. Who is using Group Replication in production? Except Lefred. Okay, nobody? Who does not know what Group Replication is? Everybody heard about it? Okay, at least somebody admits. Okay, good, good. Okay, let me show you a little bit what it is. So Group Replication is a Oracle-developed plugin. It's been generally available since MySQL 5.7.17. And this is the definition coming from the website. So basically, it provides a distributed state machine replication. It has a, basically any server in the group can process updates. There's conflict detection, so you can have multiple masters in theory, write to all of them, and then that will just work. Conflicts will be detected and be handled. There's an automatic membership service, so nodes can join and leave the cluster. And yeah, that's basically it. I'll explain a little bit more. But this is maybe similar to Percona XDB cluster or Galera, if you have heard about that. So it shares a lot of similarities, but it's not quite the same. So maybe it will just be a little bit more clear if I show you what the difference is with asynchronous replication. Who is using asynchronous replication for MySQL? Okay, majority of the people, good. So let me show you some of the differences. So with asynchronous replication, the delivery of messages, writes happening on the master towards the replica is happening asynchronously. With group replication, the delivery is happening synchronously. And I have some diagrams that I can show you. There's a concept of master and replicas. In group replication, you just have members of the cluster. So you have multiple masters, members is what it's called in this particular case. A replica in asynchronous replication will fetch binary logs, and then it will execute them. So basically, you have a master, writes come in on the master, the replica says, okay, give me all the writes that are happening on the master, and it will execute it one by one, or yeah, in parallel, depending on what features you have enabled. With group replication, the message executed on the on a node will be sent to all the other nodes, and they have to acknowledge, or the majority of the members have to acknowledge that they have received that message, and only then the actual transaction that is being committed will be returned okay back to the client. So this is kind of like the synchronous delivery of the message. And I'm talking about specifically the delivery of the message, and I'll show you in a next diagram how that impacts everything. With asynchronous replication, if you went to Shlomi's talk on how GitHub does it, there's a lot of external tools required in order to do failover, to do topology changes properly. So GitHub uses their method. There are many other tools available in both MySQL world and the MariaDB world. Things like MHA, you have the MariaDB replication manager that kind of have to do these topology changes. So GitHub in that case uses Orchestrator. So you might have heard about that. Well, with group replication, this is all automatic. Like members can join, can leave the cluster. There will be a leader election in case of a node disappearing. If there's a network petition between nodes, there will be a quorum will be established and figuring out which nodes are still majority and whatnot. And all of this to avoid split brain situations. Yeah. So what group replication uses is a Paxos-like protocol. So it is Paxos. They call it XCOM. It's a multiple leader Paxos protocol. And it's similar to Paxos Mencius. That's kind of like one of the Paxos implementations that exist. So what happens with this implementation is that when a transaction is being committed, so you do begin transaction, you do some select, inserts, whatever, this all happens locally on one node. And when the transaction is being committed, then that Paxos replication happens, or Paxos communications happens to the other nodes, and only when the majority of the nodes have said, okay, we have received it, then the actual application will get an okay back. So there's an increased latency time when you do commit. If you are in auto commit, so every write is a transaction, then you have increased latency as well there. You have a question? Yes? Yes. They acknowledge that they have received the message. Yes. No. No, nothing is being checked, nothing. I will show you in a diagram how this kind of works. The good thing about group replication is it's actually quite easy to set up. Fred has a talk tomorrow about MySQL InnoDB cluster, about MySQL HA Easy or something like that in the morning. So feel free to go there, and it will explain more about what group replication is and MySQL InnoDB cluster is. So it's quite easy to implement. You just do start group replication, and it should configure itself, right, when everything is done. I'll show you a little bit pros and cons of the current implementation. So there's also a integrated, and I put this between brackets, multi-node conflict detection. So you can write to multiple nodes at the same time, and they will guarantee that the data remains consistent. So there's a total ordering of writes. However, it's not recommended to be used yet, and I'll show you why that is not recommended yet, to use multiple writer nodes at the same time. But it is there. There's just a couple of issues that still have to be dealt with. So if you look at how this works, we have a master and two replicas, and a application is connected. It executes a transaction, so it will be written to the binary log, and it will be committed. It will be sent to the two replicas, to their relay log, and you can see that there's no communication going back. It's just the replica fetches that binary log event from the master, and then while this is happening, basically the master can just commit the transaction and then return back to the application, everything's fine. So this is traditional asynchronous replication. If you think about semi-synchronous replication, there's some change in it. When we execute, the application executes and tries to commit the transaction, it will be written to the binary log, and you can see that there are two replicas that are fetching this, and you can see as soon as one has received it, this is the default behavior with semi-sync, is that one node has received this message, so it hasn't been applying it themselves, so that replica didn't apply anything, it just received it in its buffer, and its relay log buffer. It will be sending that back to the master, and then the master will send an OK back. So there's a guarantee that when the master dies, at least one of the replicas should have all the data somewhere. Not executed yet, but it should have received it in a buffer. So that guarantees that there's no data loss when the master dies. So next up is group replication. And this is where Paxos comes in. This consensus is where this is happening. So when we commit a transaction, you can see that there are still relay logs and everything, but what happens is it will be shipped to all the nodes. This consensus protocol will make sure that the majority of the nodes need to send an OK back, so these lines are not here. And then the master node, this master or this node that received that write knows that, okay, the master 2 has received it. It will continue and do some certification, and then the binary log and commit like regular. So this is where this group communication happens, where group replication happens. And you can also see that there's a synchronous delivery of the message, but it is not synchronous applying of it. You could see that the actual applying of this write that happened, so if you write something on this master and you immediately read it from another master, there's no guarantee that you will see the actual latest data. So this is something you need to be aware of. So this is not fully synchronous. So it's synchronous delivery of messages. And even though this is a little bit different, this consensus protocol, this is very similar to Galera, so from Codership or Percona XDB clusters, so quite similar. Then there is a certification process, and this certification process actually is a deterministic process that on an individual, there is no communication with the other nodes except for this consensus protocol. When this transaction is being certified, it will, all the nodes will do the certification at a later stage. So this happens earlier, this happens later, a little bit later. They will come to the same conclusion, and they will see this transaction can continue or not continue. In reality, what it means that if there's any other conflicting writes happening on master 2, during certification, it will roll one of those transactions back. So all writes are ordered within the group communication, and the first one to commit wins. So it's a first committer wins kind of system. Yes? So let's say we are updating a row on a table on master 1, and we're executing it. And while this is being written to all the other nodes, this node tries to update the same row. What will happen is during this certification process, on this node, it will say, okay, I'll certify it, I can certify it, I can execute it. Master 3 will also do the same, it will not do anything. But master 2 will see, aha, I have to execute this, it has been in the group communication, I have to execute and I have to do everything I need to do because it was committed to make sure I can execute it. So I have found that there's another transaction here that has not been written to the group communication. I have to roll this one back. I cannot execute it. This is one of the cases. There's another scenario where this can happen, but that's basically how this guarantees this. So of course, if you write to multiple nodes at the same time and they update the same rows all the time, then you might get a lot of conflicts. So there is a behavioral change in the application for that. So you'll get some conflicts. Yes, the group communication has total order, correct. Yes.
In InnoDB, before that, we have implemented a priority transaction. And everything that comes from the group communication has the highest priority. So, and this is what kills the running transaction inside InnoDB on the local machine.
Thank you for this addition, Monsieur Lefred. So when would I recommend group replication to use something like this? And here's just my thoughts, is that when you have strict durability requirements, like you don't want any data loss to happen, you cannot afford to have any data loss, because as you can see here with this Paxos protocol, there is a guarantee that the majority, if you have 5 nodes, then at least 2 other nodes will have received an OK back. So they will take care of that. It's similar to semi-sync, but a lot more complex and a lot more I think, better architecture to guarantee that there is no data loss. So if you cannot afford data loss, something like group replication might be worth looking into. There's also, because of this consistency, you might have your tools that take care of a master and a replica, and you don't want to write on a replica, you put it on a read-only mode. Then when failover happens with asynchronous replication, there's like external tools that have to change the replication topology, things like Orchestrator. Well, I mean, they work well, and it's been there have been some older tools like MMM, for example. It didn't really care about consistency. It just made sure that the data, that replication was happening again at the cost of potential consistency. So data between the master and the replica could sometimes differ during failover. So this part of the design within group replication, within MySQL, it guarantees consistency across all the nodes. So that's a very, very important one. So if there's also network partitioning, so we have 3 nodes and 1 node lost connectivity, well, that node will not allow writes at that time. And the other nodes will, because they have the majority of the nodes. So that's an important thing. It avoids split brain like this as well. Another benefit is that it has a faster failover than standard asynchronous, because why? Everything happens automatically. Now, there are tools that can do this relatively fast. How fast is this happening with failover? Detect and failover, how fast does this go with Orchestrator, more or less? 10 seconds, 10, 20 seconds? Well, a group replication, I think based on the timeouts that they configured, that should be within 5 seconds. So that new leader, if you have run in single primary mode, where you only have 1 writer, that happens within 5 seconds, that has been detected. So it's a lot faster. And yeah, between brackets, as I mentioned already, you can write to multiple nodes simultaneously, although not recommended at this moment. So I spoke about group replication, but group replication is only one part of the full solution. If you think about it, this is just a way to replicate data. You need a lot more. You need to have a router, and this is what Oracle has developed, is MySQL Router, which is also open source. It's a load balancer, and it balances the traffic to the group replication to the multiple nodes, to whichever the writer node is at any given time, does the changes that if needed. So Router takes care of that. Then you also have something new, or relatively new, it's in 5.7 and 8.0, is MySQL Shell. This is to set up the group replication. You can do it manual, but with the shell, it becomes a lot easier, a lot more user-friendly to do. This is a little different graph. So basically, the client connects to the router, and the router connects to a database. Maybe in this case, this is the primary instance, and then you have two read-only instances. So the group replication takes care of like which node is read-only, and it will change as required. And then you have the shell, which is connection using the MySQL X admin API. So it's MySQL X protocol is a new MySQL protocol in MySQL 5.7. And it uses this to configure and tune and check the status of the cluster. So what I'm going to do now is I'll go over all these components, so the group application, the router, and the shell, and I'll show you some of my, what I call best practices, and also some of the features that are kind of still in progress, or things that I think like could use some changes. So thinking about this shell, I like it a lot, to be honest. This is one example on how you create a cluster. So basically, you connect to MySQL Shell. You have a a JavaScript and a Python interface. In this case, this is JavaScript. You can say var cluster dba create cluster. Later, you can do cluster add instance, and you say add that node to the cluster, and it can configure group replication and make sure that everything is working fine. Then it creates a metadata table as well in the database. And then MySQL Router would connect and read that. So it's kind of like a nice, easy-to-use solution, which works kind of well. So the whole configuration becomes easy. You can check the status, add nodes, bring back the cluster from the beginning. So there's a lot of things. Here are some issues that I found if you're using non-GA 8.0 GA version. So there are some issues. But with MySQL 8.0.11, which is the first MySQL 8 GA, they have nice Unicode support. You can see if it's secure, you get a little secure. There's a database logo, and then the MySQL. I always think it's from Fred, but it's not your ID. I'm sure this is yours, right? No? OK. So if you see those people with MySQL T-shirts, it's exactly this. So this is great. I like it. But another thing, and which uses features from MySQL 8, is that you've got two things, set, persist, and restart syntax in MySQL 8 now. So what I can do is if I spin up 3 databases, MySQL 8, on different nodes, I connect with the MySQL shell, I change the MySQL settings, it restarts the database for me. It does everything to make sure that configuration is fine. I don't even need to log in anymore. I don't need to SSH to the server, configure it. So you can do everything with the shell. So set persist is setting a variable. Set persist, for example, InnoDB buffer pool size, something to something. You can do this using MySQL syntax. No need to update the my.cnf anymore. So this is very, very easy, very nice. And then you can just do restart, and then it restarts the MySQL database. So this is great that just using MySQL remote connections, you can just tune your cluster, configure your cluster. And I think from MySQL 8.0.11, like a lot of the weird behaviors that I found are all gone. And I really, yeah, My Little Pony, I'm a big fan. It's really cloud-friendly, I would say. So it's really nice. So I'm looking forward for Oracle to develop more on these things, right? I don't know, hoping. Yeah, that's the shell. So going to group replication. There's a couple of things that I looked into. First of all, split brain. There were some issues, and since 2016 when I first looked into it, and they improved it a lot, so it gets the balloon medal of I don't know what it is. So a lot of the split brain issues are gone. I couldn't like break it. Consistency, it's really good. So if a node becomes unavailable, it will be put in read-only mode. Like all these things, it works out of the box now. So that's really, really good. So it's really kind of if you don't know the ins and outs of group replication, it will be difficult to break it. So that's good. The next thing is data consistency. So when I spoke about multi-writer already, when you say I want multiple nodes to be writable at the same time, it does not recommend it. It says there are some limitations to that. So it's not recommended at this moment. So when you evaluate it, please use a single writer mode, because there are some issues here that are reported. So here are two things, some certification that can lead to data inconsistencies. There's also some issues with schema changes, that if you do schema changes on multiple nodes at the same time of the same table, things can break as well. So keep that in mind. So at the moment, only use single writer mode, which is the default. Then in terms of usability, I have found like when you're trying and evaluating it, you might run into some certain problems. For example, I'm doing an insert into select, so insert into Morage, select from null from chez Lefred, where Demos office is null. You get this error. What does this mean, right? So, well, I don't know. However, I look into the error log, and then I see error on session 75, transaction size exceeds the specific limit. So there are still some things that if you don't know group replication, you might be confused with the error message that you get. So what happened here is the transaction was larger than 143 megabytes. So keep that in mind, that the messages you get here are not fully understandable. So what happens here is group replication is a plugin of MySQL, and you can see that there's a replication hook that plugin has in the before commit, and that failed. But the details are unspecified. Similar here is commit. You do commit, and you get got error 149, log deadlock, retry transaction during commit. So what does this mean? What happened? Well, actually, I don't know what happened, because at the moment, it's not easy. You cannot troubleshoot when these conflicts happen. When I was giving you the example where you update the same row on two nodes at the same time, there is a conflict, and one of the transactions need to be rolled back. This is the message that you'll get. And at the moment, even in performance schema, error log, there is nothing that you can actually see why this was. So there's no detail. So troubleshooting that is still difficult. Another one here is that when I do, this is specific to DDLs, create database, it's in state checking permissions for 131 seconds. So what does this mean? Well, actually, it means that that node where you're trying to write to has no quorum. It's not part of the cluster anymore. It lost network connectivity. So keep that in mind, that query will hang forever in the default setting. And this is because there is, I mentioned GR here, it's group replication underscore unreachable majority timeout is 0 by default. So it will wait forever to be joined back into the cluster. So I found some other issues. I'll mention some things. So at the moment, in terms of like how group replication works, one of the biggest things that is missing is when you want to add a node, it doesn't provision the data automatically. You cannot say I have an empty database, I want to bring it to join the group replication. It won't work. It needs to have some data already. You need to recover some backup at some point. Other tools, Coderships, Galera, and Procon XDB cluster, they automatically send the backup to the node that is new, provision it, give it the data, and then it joins the cluster. So this is not yet happening here. And some of the things that I mentioned already. I only have 5 minutes left, so need to go a little bit faster. So there's some other like usability related things. Another important one is that also when a node is not part of the cluster anymore, reads will still be allowed. So you cannot say like when you're not part of the cluster, please don't allow reads, don't error out on reads. So that's one of the issues that I think a lot of users would expect need. So what else? Stability-wise, one big issue that I have is that when you have 3 nodes and one node loses connectivity, after 5 seconds, that node will be removed from the cluster and it will never connect back again. So a small 5-second network partition will cause that node to never come back again. And that's I'm reiterating it because it's a pretty big problem, I think, because you don't have control of the network, and this can break your cluster quite easily. So this is definitely a feature request that I have. Fixed in the next release? Perfect. Thank you, Lefred. And then, yeah, some other bug. Now, in terms of performance, I have not evaluated much. This is one issue with performance drop during garbage collection, which happens every minute. But I'd like to eat my dinner first before having cookie. So I looked at the split brain and the usability first. Router, short about this. The MySQL Router is a load balancer, but it is not a layer 7 load balancer. It does not understand the MySQL protocol when you connect through it. So that's, in my opinion, a big downside. It's kind of like HA proxy. It's a layer 4 load balancer. So you have a different port for writes and you have a different port for reads that you'll get. And the writes will end up with a node that can accept writes, and the reads will end up with one of the other nodes. There are some routing strategies that you can choose, but that's about it. you can't even see with MySQL Router what the status of the router is. You can't see anything. So I'm a bit not happy with it. And these are all the limitations that I found with Router. There's no read-write splitting. There's no query caching, no connection multiplexing. There's no way to get the status. You cannot set the rules and say, send that there, send that there. There's no traffic mirroring, no firewall capabilities. These are all the features that ProxySQL has. So I recommend that if you want to evaluate group replication, use ProxySQL, which is open source. There was a talk about this earlier today from Marco. I don't know if there's another one coming. But ProxySQL works fine with group replication, and it has all this transparent read-write splitting, all these things, settings. You can do a lot there. So I definitely recommend that over Router. So there are some best practices that I have. Always in this solution have an uneven amount of nodes. Have 3 nodes, 5 nodes, 7, but maybe not, and that's the maximum. So why is that? If you have 4 nodes and 2 nodes can still connect to each other but not to the other, there's no majority. So none of the nodes will actually accept any reads, any writes at that moment. So you need to have an uneven amount of nodes for quorum calculation. And of course, use a better load balancer. I've mentioned. There are some settings that I recommend, and I'll go very fast over them, that if you want to use group replication, I suggest to look into all these settings. And then if you're not using 8.0.11, these are additional settings that I definitely recommend to set as well. And I'll go over them because I don't have much time, but basically set super read only on. When you start MySQL, it will be read-write mode. And then the group replication plugin starts. Well, best practice, make sure your my.cnf has super read only on, and group replication will turn it off again. So you don't create a split brain if you just say stop group replication or restart the database without the plugin. So that's something that I've ran into, me as a bad user of this tool. SSL mode required, I think that's pretty good. Disable all these storage engines, because this is InnoDB only. So only the InnoDB storage engine is supported. Transaction size, by default, 802 and bigger. 143 megabytes is the largest transaction you can send through this. You will get an error if it's larger. You can set this change this to 1 gigabyte, but it will use a lot of memory. Keep that in mind. You might run out of memory. And the rest I'll go over. So there were some others, but these are when you're not using 8.0.11 latest versions. So you can look at the slides afterwards. I need to be able to have the other person present the last slide. So in terms of limitations, what do you have? Get lock syntax, statement-based replication, large transactions is not really optimal. Select for update, not supported. No IPv6, only InnoDB. You cannot have consistent reads. So reads can still read older data because applying of the transactions is not synchronous. You need to have primary keys on all the tables. It's a requirement. It's recommended anyway in MySQL, but this is definitely enforced when you use it. So my general view on group replication is that it's great now because the split brain prevention is good. The MySQL Shell is really, really starting to show like it's easy to use and it works out of the box. Just with a couple of commands, you have a cluster up and running. Some of the lesser things is that so many of the things that I showed, but you can't block reads on partitioned nodes. There is no easy way, and hopefully that's fixed soon, to know if a node is writable or not. You need to do your own manual quorum calculation in your head to be able to have it, or use a stored function to calculate that. So it's hard to see what the status of an individual node is. There's no automatic node provisioning, no synchronous reads. So when you write something, it's in the cluster, that to make sure that any read you do will make sure it reads the latest data. That is not possible here. And these are things that Procon XDB cluster and Galera cluster do have. And the worst thing for me is that the nodes don't reconnect. When they lost connectivity after 5 seconds, they can never connect again. You need to do stop group replication, start group replication. So definitely not the best. So my opinion, if you're using MySQL 5.7 GA, I don't really recommend you to use group replication, but when you're ready for MySQL 8, which is GA, but only recently, I'm a bit like, oh, maybe not. So here's some extra additions. Always use ProxySQL, I would say. Group replication, I'm a bit, if you're like a user that just wants to use it immediately and run it in production, I would say no. But if you're like an early adopter, definitely recommend it. It's the feedback that Oracle needs to be able to like fix these issues. And but these types of presentations that I give, they did fix a lot already. So they're very receptive on feedback and want to implement all these things. So that's really good. But other than that, make sure you know you're an early adopter when you test it, and make sure you're ready to just post some of these issues or run into all of these issues that you've had. So I've had customers in a previous job I was that run into many of these issues. So run these best practices that it's in the presentation. We'll upload them somewhere. They're on SlideShare already, and test thoroughly. Just to summarize a little bit, so it was bottled at the end of 2016. So if I compare it to wine, it has a delicious gem, still youthful. It's very enjoyable for connoisseurs, has great legs, nice structure, but it needs some more decanting and aging before I would recommend to use it. And this is my slide, 90 points. Thank you. Any questions? Or do we have no time? I don't know. 2 minutes. Yes, I will post the slides. It's almost pretty similar. Yeah, it's pretty much. There are some changes, but yeah. Yeah. So in group replication, it's Paxos based. So the majority of the nodes needs to say that they have received it. With Galera, every node needs to say that they have received it, and that's kind of the difference. It's not commit as well. It's similar. The applying is still asynchronous as well in Galera. So. There is a way to figure it out. You can read some performance schema table. Fred has a stored function that shows you how many transactions it's behind. Yep. For GTID based, so it uses GTIDs to figure out if a node has all the data or not. And this is built on GTID, group replication. So yeah.
One last question.
Yeah.
I was told that it's enough that one node has high latency network and everything gets done.
That is in Galera very much so. In group replication, if you have 3 nodes and there's one slower, that does not affect, if latency-wise, that does not affect. 5.
If you have 3 nodes, every 3 writes, you will get affected by the latency because there is
a token.
To say, do you have something to say? Because you're always late. And you have to say, no, I have nothing to say. You need to wait for, I have nothing to say. So this takes time. So if you have 3 nodes, one is, I will talk about that tomorrow also, but it's it has to, you will be affected every 3 writes.
So every 3 writes will be high latency commit.
You will pay the price of that latency.
Yeah.
The next writes will wait for that.
No. Then you wait for this wait.
No. The question is,
if you write
fourth commit, will it wait for the high latency third commit, or will it just commit and then?
If you do it at the same time, no. There you don't wait.
So this is it's a multi-leader Paxos protocol, and in that multi-leader, it moves the leader somewhere else all the time. So that's why you can write on all the nodes together. But still, they are not at the same time. There's only one leader in the background. I don't know if it's every 3 commits, but there's like time slots, right?
If you have 5, it will be every 4.
Yeah.
But the thing is that the design was made to have multi-writer. Then we went to issues where people doesn't know their workload, like they have large transactions, hotspots. Then they have issues, or if they have a cascade for entities, because InnoDB is not yet able to know which one would be the next one, so we cannot certify them. We are working on that. So this is kind of limitation. If you check my blog, I explain all that kind of stuff that explains why. And this is why we recommend to not go full writer. If you don't do that, and if you know what your workload, you can write everywhere.
Yep.
So that's the difference. But the design was made to write everywhere.
Any other questions from anybody else? No? Yeah. Thank you.